Over 50 million years ago, humid prehistoric forests spanned the Earth under a dense, warm atmosphere. Towering ancient pines and giant redwoods dominated the damp landscape. Atmospheric oxygen levels reached extraordinary heights, feeding a thriving insect ecosystem. A wind fracture causes a deep fissure on the thick bark of a giant conifer. Deep within resin ducts, viscous terpene-rich sap builds up immense internal pressure. A thick droplet of clear golden resin slowly emerges from the bark fissure. This organic fluid serves as the tree's primary defense against fungi and boring insects. Sunlight hits the emerging bead, creating brilliant golden refractions within the sap. Volatile aromatic compounds evaporate, spreading a sweet resinous scent through the forest air. Attracted by the scent, small flying insects begin hovering round the glistening trunk. The resin droplet expands, its mass pulling it downward into a slow, heavy drip. Microscopic air bubbles form as the resin encounters ambient humidity on the bark. These tiny spheres trapped pristine samples of Earth's ancient oxygen-rich air. A second layer of sap trickles over the first, creating distinct stratification. A primitive worker ant climbs the dark pine bark toward the sweet nectar. Its antennae vibrate, detecting chemical signals from the resinous pool. A gust of wind shakes the high branches, displacing a heavy bead of fresh resin. The drop falls smoothly through the humid forest shade. It impacts the trunk right beside the path of the foraging ant. The sticky puddle forms a silent, inescapable trap on the bark surface. A small prehistoric beetle crawls along a mossy ledge toward the tree. The forest buzzes with life, oblivious to the quiet drama on the conifer trunk. The tree continues to pump sap continuously from its open bark fissure. The outer edge of the resin begins to firm up slightly in the ambient forest air. The trap is set, glistening under the prehistoric canopy. A primitive mosquito alights on the edge of the resin pool to drink. Surface tension and high viscosity immediately anchor its delicate feet. The insect beats its wings violently, attempting to pull its stuck limbs free. Every wing stroke only pulls its body deeper into the sticky liquid. Overhead, a fresh pulse of sap breaks loose from the bark wound. The viscous surge flows completely over the mosquito, sealing it instantly. Deprived of air, movement ceases as the resin envelopes the creature fully. Compound eyes, delicate wing veins, and fine leg bristles remain perfectly intact. A small hunting spider approaches the resin surface, targeting the insect. As it steps forward, its forelegs become trapped in the sticky perimeter. It pulls back forcefully, but the viscous bonds hold fast. A secondary drip engulfs the spider alongside its intended prey. Falling botanical fragment soak, trichums, and pine needles settle in the sap. These organic inclusions form an ecological snapshot of the forest floor. Multiple resin flows accumulate over weeks, forming a thick protective shell. As night falls, cool temperatures slow the evaporation of volatile terpenes. Morning dew forms water droplets on the hardening outer skin of the resin. Loss of lighter oils turns the sticky sap into firm, semi-hardened copel. Trapped air bubbles are compressed as the outer shell shrinks slightly. Heavy rainfall strikes the trunk, but fails to wash away the firm copel. Over years, the ancient tree dies and slowly rots away around the copel. The hardened lump drops from the decaying trunk into the damp forest leaf litter. Anaerobic conditions inside the sap prevent microbial decay of the trapped specimens. Biological time stops completely inside the airtight resin capsule. Sediment begins to cover the copel, sealing it off from the atmosphere. Buried beneath accumulating river sediment, heat and pressure begin to rise. Geological burial cuts off all exposure to oxygen, halting oxidation. Over millions of years, thermal heat induces cross-linking of organic polymers. Volatile terpenes gradually escape, hardening copal into true amber. The material achieves a Mohs hardness of 2 to 3, making it durable. Heavy layers of overlying rock exert hundreds of atmospheres of pressure. Inside, ancient air bubbles retain their original atmospheric pressure and gas ratios. This trapped air contains 30% oxygen, higher than modern levels. Tectonic forces shift continents, uplifting ancient forest beds into seafloors. Glacial periods sweep across the globe, grinding upper rock formations. Deeply buried amber deposits remain untouched by surface erosion. Glaciers melt, submerging amber-bearing strata beneath ocean waters. Anoxic salt water preserves amber for eons without chemical degradation. Subsea currents slowly erode the surrounding blue clay matrix. Having a low density, raw amber floats buoyantly in dense salt water. Storms over the Baltic Sea agitate the shallow coastal ocean floor. Floating amber nodules are swept inward by powerful breaking waves. Waves deposit the raw gems onto wet pebble beaches at dawn. Unchanged by tens of millions of years, the organic gemstone shines. The sealed atmosphere bubble remains under its original Cretaceous pressure. Thousands of years pass as early human tribes wander the coasts. Neolithic humans collect these unusual glowing stones along the shore. They hold them to the sun, discovering trapped ancient creatures inside. Amber becomes a prized trade commodity across ancient civilizations. Its greatest value, however, awaits discovery by modern scientific instruments. Modern amber extraction takes place in massive coastal open-pit mines. High-pressure water monitors blast away dense clay layers to free amber deposits. Rough, unpolished amber nuggets emerge from the washed clay slurry. Miners systematically collect the exposed raw specimens by hand. In deep waters, divers harvest amber dislodged from subsea marine deposits. Raw amber specimens arrive at specialized paleontological laboratories. Researchers inspect raw stones under intense magnification to spot inclusions. Opaque outer weathering crusts are carefully ground down using water-cooled lapidary wheels. Water drips onto the wheel to prevent frictional heat from damaging internal specimens. Polishing compounds restore optical clarity to the newly exposed faces. A perfectly flat optical window into the Cretaceous world is created. Paleontologists catalog inclusions, insects, arachnids, feathers, and botanical matter. Preserved dinosaur feathers in amber reveal ancient plumage architecture. Lizard skin fragments show detailed scale geometry preserved without decay. Ultraviolet light tests verify the physical authenticity of true amber. Fluorescence distinguishes natural fossil resins from modern copel or plastic imitations. Specific gravity tests in salt water confirm its low density relative to verified specimens are tagged with precise digital registration markers. High-resolution macrophotography rigs capture 360-degree imagery of inclusions. Optical scanners generate high-density 3D surface meshes of inclusions. Researchers worldwide access these digital scans to conduct remote studies. Physical specimens remain protected inside climate-controlled vaults. Amber forms an irreplaceable bridge between modern biology and ancient life. Its internal structures contain answers to evolutionary mysteries. Next, non-destructive X-ray microtomography looks deep inside the amber. Synchrotron, X-ray microtomography, penetrates opaque amber without cutting. High-resolution cross-sections reveal three-dimensional internal organ preservation. Soft tissues, digestive tracts, and flight muscles appear in high contrast. The last gut contents of trapped insects are identified and analyzed. Pollen grains, stuck to leg bristles, identify exact prehistoric flora species. Precision microneedles penetrate trapped air bubbles under vacuum conditions. Mass spectrometers calculate exact elemental ratios of ancient air. Data confirms hyperoxygenated Cretaceous air-fueled giant arthropod growth. Exoskeleton chitin structures maintain their original cellular geometry. Fungal hyphae, growing on trapped insects, show ancient forest decomposition pathways. Parasitic nematodes caught mid-emergence reveal prehistoric parasitic relationships. Spider web silk strands retain structural elasticity visible under polarized light. Inclusions capture fleeting behavioral moments unaltered by time. Attempts to extract ancient DNA confirm rapid hydrolysis degradation over eons. While genomic cloning remains impossible, stable amino acid chains survive. Mass spectrometry analyzes ancient protein fragments for phylogenetic mapping. Paleobotanists reconstruct microenvironmental humidity from plant inclusions. Isotopic composition of trapped moisture yields accurate ancient temperature records. Amber remains the most chemically stable natural preservation medium known. Compression fossils yield 2D imprints. Amber preserves three-dimensional organisms intact. Structural colors on beetle exoskeletons shimmer in original iridescence. Light passes through ancient resin, illuminating microscopic evolutionary history. A split-second accident preserved for 90 million uninterrupted years. Advanced optics continue uncovering unseen details within known specimens, decoding the chemical and biological archives sealed in golden time. Amber stands as nature's most complete chronological capsule. It bridges the vast divide between deep geological eons and humanity. Museum visitors gaze upon organisms that lived alongside dinosaurs. A young child observes a prehistoric ant, frozen mid-stream. The insect inside faces an era millions of years beyond its own. Gemologists value amber for its warm brilliance and organic rarity. Artisans shape raw amber into fine jewelry, preserving inclusions as natural art. Yet its supreme value remains scientific record of Earth's atmosphere. It serves as a stark reminder of planetary atmospheric evolution. Modern pine forests continue oozing resin, renewing the cycle. Insects today encounter sticky resin, repeating ancient ecological encounters. Geological processes operate silently across vast spans of deep time. Trapped air bubbles provide baseline data for planetary atmosphere research. Understanding ancient climates helps climate scientists model future shifts. Amber preserves not just organisms, but an actual breath of ancient air. A liquid drip transformed into an indestructible geological archive. Immune to decay, it preserves prehistoric moments against time. Each specimen holds a physical chapter of natural history. Through amber, the prehistoric world remains permanently accessible. It remains a frozen droplet of time suspended in golden light. A complete microworld, locked in ancient tree resin, preserving ancient atmosphere and life for eternity. Nature's ultimate physical record of prehistoric Earth. The story of Earth's air and life, trapped in resin. The frozen droplet of time, amber.